In this video, we're going to use the empirical rule to answer some questions regarding the probability of an event occurring. We have a normal distribution. That's important to know. And we'll look at the standard deviation and the mean and the data that we have. So here's the figure of the empirical rule and how it spreads out. With these percentages, we have the 68% is within 1 standard deviation of the mean, 95% is within 2 standard deviations, 99.7 within 3, and the rest is encompassed 100%. And within that, we have these sections, just so to break it down a little bit more for you to see. So each section is labeled there. So in this example, we're going to find a percentage using the normal model, draw and label the model, and shade the area or percentage that you want to find. In this case, our mean annual rainfall in Portland is 40 inches with a standard deviation of 8 inches. So that's the given information. We're told that it's a normal distribution. So here's our graph that we could just sketch a little mound here. And remember, the mean is mu, and the standard deviation is by this lowercase sigma. So we're looking at standard deviation. For this one, we're asked what percentage of the time is the annual rainfall between 32 and 48 inches. So to write out our data here, we can write X is our random variable for rainfall. We have this symbol here is a tilde. We have the capital N is for normal, telling us it's a normal distribution. 40 is our mean. 8 is our standard deviation, or our spread. And then we would write our what we're working between for our inches: 32 less than or equal to X, less than or equal to 48 as such. And we could shade that area in. So what I've done here is mark up the sketch. I put 40 in the middle, just right here, 40. That's our mean. And then the standard deviation is 8. So every little segment here, we add 8. So we have 40, 48, 56, 64 to the right-hand side. And for the left-hand side, we're going to subtract 8. So we can set up our little number line under the curve there with those values. So that's our actual data. And if we're looking at 32 to 48, what's in between there, we have this highlighted area. And if we match that up to our empirical rule above, we can see that would be 68% of the time. Okay, so we would just kind of write a little phrase or give some context, some units. So we'll jot down a sentence for that. So our answer is about 68% of the time the annual rainfall would be between 32 and 48 inches. So now we have another graph below in question. What is the probability that the annual rainfall is more than 48 inches? So this time we want to write it as X is greater than or equal to 48. So we're going to be looking at what is greater than 48. So we look here, it's going to be what's more than 1 standard deviation above. So remember, probability or percentage is the area under the curve here for a normal distribution. And we go back to our empirical rule, we're looking at this section here where we have 1 standard deviation. And we would have 13.5, 2.35, and 0.15 if we wanted to add up all those little segments there. So go ahead and do that. And you should get 16. And try to put that in a sentence. Just pause the video and write your answer down. And then check back. So our answer would be about 16% of the time the annual rainfall would be more than 48 inches. Actually here I want to change my little symbol to just be a greater than for this problem. Although for these it really doesn't matter if you enter it as greater than or equal to when we use the technology. But technically it doesn't say at least. So now there's a couple more problems that we could go through. Try this one on your own. What percentage of the time is the annual rainfall 24 inches or less? So remember, you're going to start with your mean and then add 8 for each standard deviation. And then you're going to subtract to get the left side. So set up your graphs that way to start with, and then pick your cutoff point. Try to write your inequality, and then use the empirical graph to solve that. So hopefully you have that in your notes. So if you're just writing on paper, I'll put this back here so you can sketch it out and write the data down. Okay, so here's the setup for part C. 24 inches or less. I wrote my cutoff line at 24 and shaded to the left. And I could write that as X is less than or equal to 24. And I would go up to my empirical rule. And that was actually we have to pay attention to what standard deviation that is. And that was 2 standard deviations away from the mean. So we're looking at this part right down in here. So we would have 0.15 plus 2.35. And we get 2.5%. I'm just leaving everything as percentage. So the answer for that one is 2.5%. So let's put that in context. Go ahead and jot that down. Now for the last one, we can only get a rough estimate because as you can see, the cutoff line, 54 inches or less, doesn't fall on a precise standard deviation. So we can use technology to find that out. We can get an estimate. We can look back up to that and say, well, it's about 90, 6% maybe. We know it's less than where the 56 would lie, but we don't know precisely. So we could say approximately or less than. So we're going to use a different technique. We're going to use some technology in order to help us with that. And you can use GeoGebra or Staplets, whichever you prefer. And we'll show you how to put that in. So we are going to write out our inequality, what our cutoff would be. We'll jot that down here. So we would have X is less than or equal to 54. We know that we have our X tilde, and then we'd have our normal distribution, and our mean is 40. and our standard deviation is 8. And we can use that format in either GeoGebra or Stoplets. Okay, just to note here, it's our random variable, normal distribution. We put our mean in first and then our standard deviation. So I'm going to jump over to GeoGebra right now to show you how to do that as well as Stoplets. So I've gone into GeoGebra Classic, and then we're going to click the menu here. So we click on that symbol, click the 3 dots, and then instead of spreadsheet, this time we're going to use probability. So we have this, what looks like a normal curve there, and we're going to enter in our data. So we want normal. We want this to say 40 because that's what our mean was. In our standard deviation, we're going to click on that. You have to erase what's there. You got to make sure you add the new thing in and overwrite it because it'll always hold what it most recently had. So then we are going to go down here and we want what is less than. I'm just gonna flip back here real quick so we can look. We wanted 54. We want x less than or equal to 54. So if we want a less than situation, we want the left side. So we're going to click this little icon and brace that has, if you hover, it says left-sided. Then we click there and change that number to say 54. And again, remember, it doesn't really matter if it says less than or equal to or less than. You're going to do the same process there. And then when you enter that in and hit enter, you can see it will equal 0.95994, and we get our diagram shaded. That's why it's important you sketch out your cutoff, because if you accidentally hit the wrong one, it will be noticeable. You'll see that it's not correct. And we had our estimate, and I think we were talking about like, oh, maybe 96-ish or whatever. So that's pretty close actually, 0.95994. And we can write our sentence here about 95.994% of the time the annual rainfall will be 54 inches or less. And we can use this for the other data that we did use before and compare it and see that we're going to get a more precise answer, hopefully, using the empirical rule for percentage of rainfall 24 inches or less. We had about 2.5% of the time. If we put it in, just changing the number here, I've changed to 24 and I get 0.02275, which would be 2.275%. If I want to do this problem B, more than 48 inches, then I'm going to leave the same mean and standard deviation because that's the same problem. It's just varying what the inches are. But I also have to change how this looks. I'm going to do the right-sided, and I'm going to change the number as well to, we were looking at more than 48 inches. So we pop in 48 inches. And we had about 16% using the empirical rule. And with this, we get more precise, 0.15866. We'll do more problems using the normal distribution. I just wanted to show you briefly how they, compare. When we're doing the first one, back to that, between 32 and 48 inches, we're going to use this icon here. So we have to change that as well as change our numbers. So this one, 32, we already have 48 there, and that would be 0.68269. And you can double check that your graphs look similar. And we had about 68% of the time using our empirical rule, and now we're just a little more precise with 68.269. That's GeoGebra. Now a quick look at how to enter it into Staplets, and then we'll do some more practice problems in a different video. Okay, so to use Staplets, we're going to go to staplet.com, and then we're going to click under the probability category. We're going to click normal distributions. And we need to put our mean in as 40, our standard deviation as 8. And we also have to make sure that we're looking at our operation is calculate an area under the normal curve, because there is a different option that you're calculating the value to the corresponding area, which we'll look at later on how to do that. So this one, we're just looking at the area under the curve, which is the same as probability, which is the same as your percentage. So once we do that and we set our mean and our standard deviation, we're going to click plot distribution. That pulls up our graph. And then for this first one, area between 32 and 48 is what we're looking for. So we set this drop down menu to between two values, which is kind of nicer than GeoGebra with the icons. It can get a little bit confusing sometimes just looking at those. And we have left boundary was the 32, right boundary is 48, and then calculate area. It's just giving you the Z values as well, or the number of standard deviations from the mean. And we get 68.27%. So Staplet is going to give it to you in percentage. Again, you can change your rounding as you see fit. You can adjust down here or as indicated in your homework problems. If we want to find area more than 48 inches for this part B, we're going to say area to the right of a value and put in just 48 and then calculate area. Again, we're leaving our mean and standard deviation the same. And again, we get almost 16%. If we want to do these others here, the rainfall less than 24, we would just do left of a value. And if we want to do less than 54, so less than 24, our area was 2.28%. Less than 54, 95.99%. So they're all, it's a little bit different depending which technology you're using, but the rounding should have a buffer. It has a margin of error. But if you're finding you're getting marked wrong on anything due to just that little bit of a difference, certainly let me know, especially if it's a quiz. But look at your rounding. You might need to change that. I think most of them you can go out a couple of places. So I hope that helps you see how the empirical rule relates, what the sketch should look like, and then just entering it into technology and getting the job done fairly quickly. But if you don't have the understanding of the long way around doing it, I think you could possibly just choose something wrong in the drop down menu by accident, or just click on the wrong thing and not really notice it. So that's why it's important to check your sketches and see how they line up. So that's it for this video, and we'll do some more problems in a separate video. Have a great day.